we can go ahead and start. So, did you read section 4.1 or not? So circle that yes or no, at least look over this. So this material is not on the exam, but in some sense it's review because we're just doing in the continuous case what we did for the discrete case. So the ideas should sort of line up quite well and kind of solidify some other ideas that you've had. Abby?
Is the moment generated functions going to be on the next test?
Sure. Actually, there's probably like a 12% chance it'll be on the next test.
Can you walk us through that probability?
What's that?
Can you walk us through the probability?
Of why it's 12%.
The 12%.
Oh, why it is? Because I don't know what's going to happen in the next 2 or 3 weeks. I don't know.
It's the confidence.
I'm excited about that. But. Okay, so it's very important to specify your functions domain. Just as like it is for the discrete case, it's very important that you do that in the continuous case as well. Style points, nonetheless. We need to give different expressions. So remember that in the old days, which is your current days, the CDF was given by the summation for y less than or equal to x, p of y. So you summed up all the probabilities before f of x, and this is for the discrete case. Okay, so, and this cumulative distribution function is nice because you do a lot of calculations, and those kind of formulas that you have, you should keep reviewing those. Now, if you have a continuous random variable, then the probability density function will be a PDF f such that the cumulative distribution is the integral from minus infinity to x of f of t dt for all f of x. So what's happening is you might have some sort of little f here, and the area here, f of x, will be the probability. And this little f right here is your PDF. So you integrate, and up to this point gives you the cumulative probability up to that value. So rather than a summation sign, you have an infinite summation sign, which is what the integral is. It's in some sense, under certain situations, you could think of this as a infinite sum. Infinite sum of infinitesimals, the Riemann sum, and many things like that. The idea is, like on your book on page 139, here is a discrete probability distribution function. But if you have smaller and smaller intervals, here's another discrete distribution. But if you get small enough, then you just might as well represent it by a continuous curve. Okay, so when you have a continuous curve, the PDF doesn't really give you much in terms of the probability. It's really the cumulative distribution that does the work. So in general, if you have the probability of a less than x less than or equal to b, remember this is the formula that you got for the discrete case. Remember the discrete case, you had to like go down a little bit. If you included a, you had to go to a minus to include the probability all the way through. In the continuous case, this is in general, what you would have then is the integral from a to b of f of t dt. Just our good old fundamental theorem of calculus. So if this is a and this is b, the area here would give you the probability. So again, notice that we reviewed this part for the discrete case and that reviewed this idea for the continuous case. Now, those, just have a brief conversation with your partner at your table. What is the probability that x equals c for a continuous random variable?
I think it's 0, like the area of
I don't either.
Continuous are, what is the probability? It's continuous, so, going into a single.
Okay, so what is the answer that thou has come up with? The probability of x equals c is actually 0. That's exactly right. Do you have a reason for that, Andrew?
Well, a single point or value doesn't have an area.
So it's just sort of an infinitesimal line segment which has no area, and since the area for a continuous random variable gives you the probability, there's no probability for that. So, Mitch?
What is C?
C is just a number.
Just random number.
Well, a particular real value number, so every value of C would be a real number between negative infinity and infinity. There is a philosophical issue here. Yes, Gabe, you're going to raise the philosophical issue?
No, I have a question regarding why it's 0. How come it's not just little f of c?
Yes. The reason is that it's the area between these two, and so you get a height, but there's no width.
Okay.
0. And actually, if you really want to get philosophical, if you pick a random number between 0 and 1, there's a 0 chance that you'll pick, almost always never pick that number. It's a probability of better 0 or something. But that's just because we usually think of numbers like 1, 2, 3, 4, 5. But you could get a repeating decimal that's so convoluted or whatever that you would never exactly get that particular number. Okay. Any other questions for the philosophical side of life?
And Dr. Case, when you're saying, like, you won't guess that particular question, that particular number, you're saying what C has been identified to be?
Yeah, if you theoretically picked a number between 0 and 1, and every number had an equal likelihood chance, the probability of you picking that number is essentially 0.
And that number is represented by C?
Yeah. Okay, so good news for continuous cases. Unlike discrete distributions, which you must take care of, particularly on this exam tomorrow, you can be completely cavalier about whether inequalities include less than or equal to, greater than or greater than or equal to. It doesn't make as much of a difference with continuous random variables. Now, generally, we usually specify continuous distributions by their PDF, and then you calculate the CDF from that. Generally, the PDF gives us what we need to integrate across, but a specific value of the PDF generally is not very helpful.
Oh, okay. Well, I was just thinking, how do you even calculate the PDF if, the probability for each individual number is zero?
That's the beauty of calculus, where you add up infinitely many things and you get something finite. Ask that question again in about 5 minutes and see if I have a better answer for you or not, or if you're sufficient, if you still appreciate the answer I gave you there. Let's first of all, if you have a continuous random variable with a cumulative distribution function f and a probability density function f, then f prime of x will be little f of x. F of x will always be positive, or 0. And if you integrate from minus infinity to infinity f of t dt, you will get 1. Yeah, because that's a probability. It has to be a probability measure if that's going to work. The first one is just the fundamental theorem of calculus. the first derivative, the derivative of the antiderivative gives you the function itself. If it's going to be a valid probability, it's going to have to be 0 because otherwise you can't have a negative probability. From those 3 axioms, you have a probability that there's still an 86% chance that you'll have to say the 3 names and give the 3 properties on the exam tomorrow. It's a subjective probability is what it is. The theoretical idea is if I wrote this test over infinitely many times, 86% of the time, that question would appear on the exam. And these follow from the properties of CDFs that we have from earlier. Okay, this, for some reason, should not be that difficult, but it can be. And the reason is it's this idea that you have an area, probability, and you have a value on the x-axis. So it's going back and forth between the value on the x-axis, which could be any number, any real number whatsoever, and the probability, which must be between 0 and 1. Okay? So there's this kind of symmetry between the value on the x-axis and the probability. So first of all, a percentile then is the solution to this equation. From minus infinity to eta of p, you get the probability of p. So the picture here is we've got this kind of probability, and this area here is the probability p. The scaling down here would be eta of p. Greek letter eta, and that's supposed to be a p. So this is the percentile. So if you're in the 10th percentile of your class, you beat 10% of the other students. You scored higher than that 10%. I think I calculated this once. I think I'm in the 91st percentile of male height. I think. Actually, it was a while ago. I may have shrunk then. So I am taller or the same height of 91% of males across the globe. Eta of 0.5 is called the median and is sometimes used at mu tilde. So if this was mu of 0.5, the median, you'd have 50% over here and 50% over here, and you might represent that by mu with a tilde over it. Okay, let's turn the page to page 48. And why don't we just have you sketch the probability density function. Why don't we have you all do part A, you in the middle do part B, and you over here do part C. Go ahead and sketch the PDF of that. Your C.